So here's the final design for the dream pipe. Originally we decided we wanted to go with PVC piping, a lot more of it, and then also brass, but instead we decided to go with copper because it has a much higher conductivity than PVC and brass do, so we figured it would work out the best for our project. So to start with, on the right side is the evaporator, which is the part that will be exposed to the hot water and will heat up the low pressurized water on the inside of the heat tube, which will then evaporate the water. Because of being at a lower pressure, has a lower evaporation temperature, so then the evaporated water will go up the tube, which is heading to the left direction, and through the adiabatic section, which is the PVC valve right there that you see, and then the evaporated water will go up towards the condenser, which is the second longer part of the copper tubing that you see, and the condenser will be colder than the evaporator, which will cause the evaporated water vapor to want to cool down and condense on the inside of the pipe, which will then release a lot of heat to the surrounding air temperature. And after the heat transfer of the condenser, the condensed water will then want to go back down the heat pipe, which, as you can see in this diagram, it can follow this wicking pattern, which will go all the way down the heat pipe and go back into the evaporator, causing the liquid water to heat up again, which will then evaporate, bringing it back up to the condenser, which will then release more heat yet again, and it'll keep following this pattern until the water on the inside of the heat pipe will stop boiling, which should be around 40 degrees, but because of the non-ideal situation our vacuum pump was in, I don't believe that we were getting the right vacuum that we were getting, because we could feel it stopping boiling around 70 degrees, whereas if it were at 13 kilopascals inside the tube, which is what was estimated, then the boiling temperature on the inside of the water should be 42 degrees Celsius, but we think that it wasn't that ideal, and the boiling temperature was about 70 degrees, meaning that the pressure on the inside was right around 43 kilopascals, which is about half of atmospheric pressure. After fabricating our device, which involved a lot of soldering of heat pipes and some yellow tape to put around the threads so that it would create a tight seal whenever we screwed a component in, but then we hooked up our device to a vacuum pump, which is supposedly be able to bring the pressure of a control volume down to around 3 kilopascals, and then after pumping all the air out that we could, we would close that yellow valve that you see there, and then we unattach the vacuum pump tube from our heat pipe, and we open the red valve that you see, which is holding a certain volume of water in the evaporator section, so that the vacuum pump wouldn't be able to suck any of the water into it, because that's bad for a vacuum pump. To start our experiment, we first boil 1 liter of water, approximately, a little bit more, and then after it's boiling, as you can see it's boiling in the video above, we want to pour it in a 1 liter beaker as a control volume, where we stick the heat pipe in, and then from there we test out how much temperature change we can get. First we measured a control with the water going in the beaker and then cooling off on its own naturally, so that we could compare it to how much of a difference it would make with our heat pipe inside of it. The temperature change of the water without our heat pipe in it is shown now, which gives a delta T, or temperature difference, of 19.5 degrees. We then put our heat pipe in the hot water and we test it for 15 minutes to see how much of a temperature difference it creates. And as you can see, you can actually see some of the heat waves flowing down from the evaporator, meaning that it's actually cooling the hot water in the beaker, which is exactly what we want it to do. After recording a couple of trials, we've realized that it is actually making a difference. Shown are the results of our trials, our best trial actually, which gave us a delta T, or temperature difference, of about 26.5 degrees, which is quite a bit more than 19.5. And here's a graphical visualization of those results. Doesn't look like a lot, but it's definitely a bit of a difference compared to natural convection of just the water being cooled by the surrounding air temperature. Thank you for watching, and I hope you enjoyed our dream pipe.